In this video, I want to talk about a really important property. I think it's really important but often overlooked is this idea, this thing called the commutative property. And so it sounds scary, maybe weird. You probably have never heard this word commutative before, but we'll see that it's actually it describes something very simple. So I want to ask you, what if you had 1 plus 2? You probably know that that's 3. What if we reverse the order of that operation? So what if we did 2 plus 1? Well, that still equals 3. Okay, what if we had 1 plus 2 plus 3? Well, that's 1 plus 2 is 3, plus 3 is 6. What if we had 2 plus 1 plus 3? Well, 2 plus 1 is 3, plus 3 is still 6. 6. Okay, what if we had 1 plus 3 plus 2? Well, 1 plus 3 is 4. 4 plus 2 is 6. And I hope you get the idea. There's 3 more ways I could jumble these numbers up, and we'll see that every time we do that, it doesn't matter. When we're adding like this, we'll always get the same answer. And also, it doesn't matter how many numbers you're adding. I showed you an example where you're adding 2. I showed you examples where you're adding 3, but you can add 5 numbers and jumble them up any way you want. The sum will always come out to be the same. You can have a million numbers and jumble them up, millions of different ways, and you'll get the same answer. And so that's actually a really useful thing to recognize and to always kind of keep in the back of your mind when you're doing math, especially algebra. And this might seem trivial, might seem so simple that it's almost not worth stating that you can do this. But I assure you that later on in algebra, you're going to come across cases where knowing that you can do that will be the difference between knowing how to solve a problem and not knowing how to solve a problem. And the examples are too in-depth to show here, but I assure you, if you keep this in mind, it's going to come in handy later. So this, by the way, this sort of property that lets you do this, or not lets you do this, but says you can do this and you're not going to change the value, we call this, and we're doing addition here. So this particular property is called the commutative property of addition. And the more formal way of saying this or defining this is we basically write it as, look, if you have some number, any number, doesn't matter, A, and you add it to some other number B, it's the same thing as if you were to write B plus A. You'll get the same answer. So their sums will be equal. And like I said, it doesn't matter how many numbers you put there. It doesn't matter what the numbers are. If it's all addition, you can move those around as many ways as you see fit. And there's another sort of like non-formal way of describing this. People call it the order doesn't make a difference. Order doesn't make a difference rule, because the order in which you add doesn't make a difference to the answer that you get out. Okay, and then if we want to see if we can do this on any other operation, let's try the next logical one we want to do. Let's try subtraction. So we're going to test this really quick. Oh, sorry. One thing I wanted to talk about before is this idea. I talked about this word commutative being scary. It's not. Look at this word. The root word in commutative is commute. Commute means to move around, to go from one place to another. And that's what our numbers are doing when we use the commutative property. We are moving them from one place to another. We're jumbling them around. And we can do it, and it doesn't matter. It doesn't affect the outcome. And so that's something you can do with addition. You can make the numbers move around with addition. What about subtraction though? So do we have a commutative property of addition? So commutative property, not addition, sorry. Commutative property of subtraction? Well, let's try an example. So what if we did, well, let's just do what I did for the first example with 1 and 2. So what if I did, not plus there. Let's do 2 minus 1. What does that equal? 2 minus 1 is 1. What if I switch the order? So what if I did 1 minus 2? Well, that equals negative 1. It's a different answer. And so we see that we can't just move the numbers around without doing anything with this sign. And so there is no commutative property of subtraction. However, I will show you a way you can use commutative property of addition when you have subtraction. So the proper way to use the commutative property in this case would have been to notice that if you had 2 minus 1, you would need to recognize that we can say this is the same thing as saying 2 plus negative 1. Now we have addition here, and we are adding a negative number. Now notice this. When we switch the order around the plus sign, we're going to get negative 1 plus 2. And that still equals 1. Negative 1 plus 2 equals 1. That's the same thing as if we had 2 plus negative 1, by the way. 2 plus negative 1 is also equal to 1. So the commutative property does not work when you're doing subtraction like straight away. You can't just leave the sign, put and then move the numbers around the way you do with addition. However, if you recognize that subtraction is the same thing as adding a negative number, you can do that. Okay, let's talk about one other special case where we can use the commutative property. Do we have a commutative property of multiplication? So commutative property of multiplication. And this takes a while for me to write. Do we have that? So let's try some examples. What if I did 3 times 2? That equals 6. What if I did 2 times 3? Also equals 6. What if we did 2 times 3 times 4? Well, 2 times 3 is 6, times 4 is 24. What if we did 4 times 2 times 3? 4 times 2 times 3. Well, 4 times 2 is 8 times 3. Well, that's also 24. And we don't have enough time to go around and try every possible combination, but it turns out that commutative property also works for multiplication. And it works in the same way. It says the order in which you multiply doesn't matter. You will always get the same answer. So it doesn't matter how many numbers you're multiplying together. It doesn't matter how you jumble them up. You'll always get the same answer. And so, again, this is really, really handy when you're doing algebra. However, and higher math even, but I can't really give you specific examples in a video like this, but I can tell you right now that it is useful, and do remember it. And also, it shouldn't come as a shock that multiplication is also commutative, because multiplication is just repeat addition, and addition is commutative. So why wouldn't multiplication also be commutative? It is inherently addition. It's sort of addition to a higher level, but what's the word I'm thinking of? It retains rather it's the properties of addition. What about the commutative property of division? So division. I'm not going to write out the whole commutative property. So what if I have, let's do 100 divided by 4. We know that equals 25. what about if we have 4 divided by 100? Well, that equals 1 over 25. Very different numbers there. This is 25 is a much bigger number than 1/25. Now, there is a situation where it kind of applies, but you have to recognize something. And you don't actually, it won't make sense if you write it that way. So instead, I'm going to write division this way. If I had 100 divided by 4, okay, well, I could use the commutative property of multiplication here, but it might not be apparent. How do you do that? You have to recognize that this right here can be split up into 2 separate numbers. It can be 1/4 times 100, right? Or you could think of a 100 over 1. If you multiply forward, you will get 100 over 4. And we could say that that is the same thing as saying 100 times 1/4. And so we are using the commutative property of multiplication. But we see we'll see why it doesn't work for division the way we tried it up here. Because if you have 4 divided by 100, you have 4 divided by 100, like that. Well, these are inherently just totally different problems or totally different values. Because this right here is, we can say that is 1 over 100 times 4. So notice that the location of the numbers in the numerator and the denominator are totally different. And so we can still use the commutative property of multiplication on this specific problem here, but notice that is an entirely different problem as the one we have up there. And so we do not have a direct, commutative property of division, but tucked away in that, if you write it out correctly, is a commutative property of multiplication. And so I want you to take away from this video that there's a commutative property of multiplication and addition, which says, look, the order doesn't matter. Add them up or multiply them up in whatever order you see fit. If it helps you to do it one way versus the other, then do it that way, and you will not change the value of the answer. So you're good. You can do that. And so we're going to explore in another video another property that seems similar, but it is a little bit different. It's called the associative property. So we'll check that out in another video.